Good evening, students. I hope you wrote today exam well. I hear that chemistry was more tougher than physics. It means many students felt chemistry than physics. Now I am going to discuss today's Kcet chemistry question paper. My name is Venkat. I have been working as a lecturer for the last 20 years, means since 2005. Okay, let us discuss today's paper, chemistry paper. First question, students. If we can go to first question, in which of the following options or the arrangement does not agree with the variation of property indicated against it? It means which of the following option is wrong. If you can take first option, students, in first option, boron trifluoride greater than nitrogen trifluoride greater than ammonia. Actual order of the dipole moment is NH3 greater than NF3 greater than BF3. Why NH3 has greater dipole moment than NF3? In NH3 molecule, all bond dipoles moves in one direction. Dipole moment is the vector sum quantity. If you can take NH3 here, 3 NH bonds, 1 lone pair on nitrogen atom. Why? Because the nitrogen has 5 valence electrons. 3 electrons are involving in 3 bond pairs. Remaining 2 electrons are present as a lone pair. Dipole moment always move towards the electronegative atom. Nitrogen is more electronegative than hydrogen. Dipole moment, bond dipole moment move towards nitrogen. This bond dipole moment moves towards nitrogen. 3 bond dipoles move towards nitrogen. This is the bond dipole movement towards lone pair. So all bond dipoles move towards the one direction. That's why NH3 molecule dipole moment is not equal to 0. This molecule has particular dipole moment. By taking NF3 molecule, nitrogen trifluoride, nitrogen, fluorine, 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 lone pair, 3 bond dipoles move towards downside, means towards fluorine atoms. 1 bond dipole move towards upside. This molecule has a dipole moment, but compare it to ammonia molecule, less dipole moment. Okay, because 3 bond dipoles move towards the down, 1 bond dipole move towards upside. That's why. By taking BF3 molecule, boron trifluoride, boron trifluoride has a trigonal planar structure. Generally, dipole moment is the 0 for trigonal planar molecules. Trigonal planar molecules. 1 bond dipole move upside, 2 bond dipoles moves downside. So net dipole moment of BF3 is equal to 0. So NH3 has greater dipole moment than NF3. NF3 has lesser dipole moment, not 0. NF3 has certain dipole moment that will be less, very less. BF3 dipole moment is the 0. This is the correct order of dipole moment of molecules. But here first option, BF3 greater than NF3 greater than NH3. This option was wrong. Means does not agree with the variation of property against it. Okay. Go to second question, students. With respect to resonance structures of CO3 minus 2 ion, means carbonate ion, which of the following statements are correct? Okay. By taking first option, all CO bonds in CO3 minus 2 are equivalent. By taking resonance hybrid structure of carbonate ion, all bonds are equivalent. Okay, by taking CO3 molecule ion, carbon, oxygen, oxygen. Yeah, this one has partial double bond character. This is the structure of CO3 minus 2 ion. All CO bonds are equivalent. This is the structure of resonance hybrid. This is not the structure of resonance. This is not structure of CO3 minus 2 ion. This is the structure of resonance hybrid. All CO bonds are equivalent. Okay. A is correct. Next, go to B. There are 3 resonance structures are possible for CO3 minus 2 ions. This is also correct, students. Why? Because C double bond O, oxygen O minus. What is the resonance displacement of pi bonding electrons? C O minus double bond O minus. In the third structure, C O minus double bond O. What is the meaning of resonance? Resonance is the displacement or delocalization of pi bonding electrons in the given structure. Here pi bond is present at upside of the carbon. In this structure, pi bond is at left hand side of the carbon. In this structure, pi bond is present at the right hand side of the carbon. Second, okay, statement is also correct. Next, the position of carbon and oxygen should change in every resonance structure. No change in the position of nuclei or atoms in the resonating structures or canonical structures. But in given statement C, position of carbon and oxygen should change in every resonating structure. This is not possible. So statement C is wrong. Next, the formal charge of carbon atom is 2. The formal charge of carbon is 0. The formal charge of carbon is 0. Okay, how can you calculate, students, formal charge of carbon is 0? Okay, formula is there. Formal charge Q is equal to number of valence electrons minus number of lone pair electrons minus half into number of bond pair electrons. Okay, in CO3 minus 2, what is the formal charge of carbon? Number of valence electrons in carbon 4 minus lone pair electrons. Number of lone pair electrons are 0. No lone pair. 4 electrons are involving in the formation of covalent bonds. Here 4 minus 0 minus half into total number of bond pair electrons. Total number of bonds are 1, 2, 3, 4. Each bond has two electrons. 4 into 2, 8 electrons. 4. So 4 minus 4, that is equal to 0. So formal charge of carbon is the 0, not minus 2. So statement A and B are correct. A and B only. A and B only. Okay, students. Let us go to third question. Given below are two statements. Statement 1. In H2O2, each oxygen atom is assigned an oxidation number of -1. In RbO2, each oxygen atom is assigned an oxidation number of -. Statement 1 is correct, students. Why? Because of H2O2 chemical name is hydrogen peroxide. Wherever you will get peroxide compound, in that compound oxygen should possess -1 oxidation state. Hydrogen has +1, 2 hydrogens, 2 into +1 +2. Oxygen has -1, 2 into -1 -2. Hydrogen peroxide is the neutral compound. In hydrogen peroxide, oxygen has -1. RbO2, rubidium dioxide. Rubidium has first group element. All first group elements possess +1 oxidation state. Here the sum of positive oxidation states is equal to sum of negative oxidation states. Here each oxygen has -. 2 into -, that is equal to -1. Statement 1 is correct, students. Next, let's go to second statement. Representation of HAuCl4. HAuCl4, the oxidation state of Rm means gold has +3. Why? Because each chlorine has -1. 4 chlorines are here. 4 into -1 -4. Hydrogen has +1. Okay. Here, how to represent a stock notation of this compound? We should take oxidation state of Rm in Roman number. That will be HAu3Cl4. This 3 represents oxidation state of Rm. Rm means gold. And MnO2, manganese dioxide. MnO2, manganese dioxide. The oxidation state of manganese will be +4. Why? Because each oxygen has -2. 2 into -2 -4. Manganese should be +4. But here given manganese 2. So this is wrong. Statement 1 is correct. Statement 2 is incorrect. So which option is correct, students? Statement 1 and 2 are correct. This is not correct option. Both statement 1 and 2 are incorrect. This is wrong. Statement 1 is correct, but statement 2 is incorrect. This is the correct option. Okay, students. Go to next question. Let us discuss fourth question. C2O4 -2 What is the name of C2O4 minus 2 oxalate ion? Stop. Let us discuss question. C2O4 minus 2. What is the name of C2O4 minus 2 oxalate ion? Go to fourth question, students. Sorry for the disturbance. Sir. C2O4 minus 2 oxalate ion plus MnO4 minus permanganate ion in the presence of H plus ions to produce XMn plus 2 plus YH2O plus ZCO2. A and X are respectively. First you have to know change in the oxidation state of element. C2O4 minus 2 give rises CO2. Oxalate converted to CO2. In oxalate ion, oxidation number of carbon is plus 3. In carbon dioxide, oxidation number of carbon is plus 4. In 1 mole of oxalate ion, 2 carbon atoms are present. That's why total change in the oxidation state of carbon is 2 into plus 1 is equal to 2. Because in 1 mole of oxalate ion, 2 carbon atoms are present. Change in the oxidation number of 1 carbon atom is plus 1, means plus 3 to plus 4. Change in the oxidation state of 2 carbon atoms, 2 into 1, that equal to 2. Okay. Change in the oxidation number of carbon is 2. Change in the oxidation number of permanganate ion. Permanganate ion MnO4 minus give rises Mn plus 2. Mn plus 2. Oxidation state of manganese in permanganate ion is plus 7. That is directly changed to Mn plus 2. That was given in the reaction. What is the change in oxidation number? Plus 7 to plus 2. 5 is the change in oxidation number. So, change in the oxidation number of manganese is 5. Change in the oxidation number of carbon is 2. For balancing of the reaction, you have to crisscross of their change in oxidation numbers. Crisscross of their change in oxidation numbers. 2 will be given to manganese, 5 will be given to carbon. So, how many moles of oxalate ion will be taken in the chemical reaction? 5 moles. A will be 5. A will be 5. Means change in the oxidation number of manganese is taken to carbon. It means crisscross of their change in oxidation numbers. 2 is giving to manganese. So B, number of moles of permanganate ion is the 2. So here A is 5. A is 5. A is 5. In which option A is 5? In option 1 is only A is 5. And asked X is also. What is X is here? Okay. Here I am taking 2 moles of MnO4 minus. So we should get 2 moles of Mn plus 2 ions. So A is 5 Okay, X is 2, 5 comma 2. 5 moles of oxalate ion and 2 moles of Mn plus 2 ions. Next question, students. Let us go to fifth question. Which of the following will not act as oxidizing agent? Oxidizing agent. This question belongs to D and F block elements. Strength of oxidizing agent directly proportional to oxidation number. Strength of oxidizing agent directly proportional to oxidation number. Here if you can take CrO3, chromium possesses plus 6 oxidation state, MoO3, molybdenum possesses plus 6, CrO4 2 minus. This is the chromate ion. Chromium possesses plus 6. Dichromate ion, chromium possesses plus 6. In all options, okay, central atom possesses same oxidation number. But students, 3 compounds are belongs to chromium compounds. But in option 2, okay, molybdenum, central atom is the molybdenum. If you can take chromium and molybdenum, both are belongs to same group. They are belongs to which group, students? Here chromium. Chromium is the 6th group element. Chromium is the 6th group element. 6th group. Chromium is the 6th group element. Okay, me chromium. Okay, molybdenum. Students, going down in oxides, stability increases. Stability increases means that compound won't be react. The oxidation meaning it means oxidation state does not changes. Oxidation state does not changes means does not change to plus 3. Why? Because of high stability of MoO3, molybdenum trioxide. But in remaining options, chromium changed to plus 3. Chromium changed to plus 3. Cr plus 3. Chromium changed to plus 3. Generally, in any group, not only in this group, in oxides, stability increases. So, molybdenum is under the chromium in 6th group. So, stability of molybdenum trioxide is more. So, no change in oxidation state of molybdenum in MoO3. So, option is the second. Let us go to 6th question, students. The highest oxidation state of manganese in fluoride is plus 4. Manganese tetrafluoride. Its name is manganese tetrafluoride. But the highest oxidation state in oxide is plus 7. Because manganese possesses highest oxidation state in manganese dioxide, Mn2, manganese heptoxide, Mn2O7, and MnF5O2. In these compounds only manganese possesses highest oxidation state, plus 7, here plus 7. MnF4, students. MnF4O2. Okay, sorry students, 5 only. MnF3O2 students. Sorry for the disturbance. Here MnF3O2 and in Mn2O7 manganese possess highest oxidation state. Here, which option is correct is here. Fluorine is more electronegative than oxygen. This is not correct option for the positioning of highest oxidation state in oxides is +7. Fluorine possesses d orbital. Fluorine does not possess d orbital. In fluorine, outermost orbit is the second orbit. In that second orbit, only s and p orbitals are present. No d is present. Fluorine stabilizes lower oxidation state. This is not correct. Fluorine stabilizes higher oxidation state. Higher oxidation state. If you can go through fourth option is the correct. Why? Because in covalent compounds, fluorine can form single bonds only. Yes, it is okay. Fluorine valency is -1. So fluorine can form single bond with the transition metals. While oxygen form double bond. It is correct. Why? Because of, if we can take Mn2O7 structure, manganese, two manganese atoms, double bond O, double bond O, double bond O. Each oxygen has 3 oxygen atoms with double bond. Mn2O7. One is the bridge oxygen. Each manganese oxidation state was 7 +7. So in covalent compounds, fluorine can form single bonds only because of fluorine oxidation state is -1. While oxygen form double bonds or not. Here oxygen is forming double bond. So fourth option is the correct. Let us go to 7th question. The calculated spin only magnetic moment of Cr+2 ion is. First you have to know, students, what is the anomalous electronic configuration of chromium. Chromium, atomic number 26. Electronic configuration is with net gas 18, 4s1, 3d5. This is the electronic configuration of chromium. Electronic configuration of Cr+2. Atom losing electrons or gaining electrons or sharing electrons from the valence shell only or outermost orbit. So chromium is losing 2 electrons. From where chromium is losing 2 electrons? From 4s orbital 1 electron and 1 electron from 3d orbital. So here, what is the electronic configuration of Cr+2? Argon 18, 4s0, 3d4. How to find out magnetic momentum? What is the formula for the calculation of magnetic momentum of atom or ion? If the ion or atom contains unpaired electrons or single electrons, that atom only possesses magnetic momentum. If the atom or ion does not have no single electron or unpaired electron, that atom has zero magnetic moment, nothing but diamagnetic. Now, chromium Cr+2 has 4 unpaired electrons. What is the formula for dipole magnetic momentum? That is equal to root n into n+2. What is the meaning of n? N is the number of unpaired electrons. 3D has 4 unpaired electrons. 3D has 4 unpaired electrons. First, all the available degenerate orbitals are filled with single electron and then paired up. 1, 2, 3, 4. 4 electrons. These 4 are unpaired. So root n is equal to 4. N is equal to 4. 4 into 4 plus 2 root 4 plus 2 6. 6 into 4 24. Root 24 is the root 25 is 5 students. Root 24 is the nearby 5, that is above 4.9. Almost 4.9 is the second option, students. Is it correct or not, students? 100% correct, students. Let us go to 8th question. Which of the following is the most stable complex? This question belongs to students' coordination compounds. Coordination compounds. Yeah, this is FeCO taken 5 means pentacarbonyl iron 0. This is hexacyanidopherrate 3 ion. This is trioxalato ferrate 3 ion. Hexa aqua iron 3. But asked here, which is the most stable complex? In given complex compounds, the complex compound which has chelating ligand, that compound is more stable. By taking FeC2O4 taken thrice, 3 minus, C2O4 is the chelating ligand. What is the meaning of chelating ligand? Chelating ligand. The ligand which forms cycle or ring with central metal ion or atom. Here iron coordination number is 6. By taking this compound, Fe coordination number is 6. Okay, like octahedron. Okay, oxalate ion is bidentate ligand, means that is a COO minus. Here this oxygen donate lone pair to central metal ion. This oxygen donate lone pair to central metal atom or ion. This is the metal is the iron. So central metal ion is the iron. This one has plus 3 charge. This is one oxalate ion bidentate ligand. This is one is your oxalate bidentate ligand. Bidentate ligand is donating 2 lone pairs to central metal ion. This is one oxalate ion. So option 3. In option 3, oxalate ligand is present. That oxalate ligand is the chelating ligand. Chelating ligand means the ligand which forms cycle or ring. This is the meaning of this is the like ring with the central metal ion. Central metal ion. This is also one ring with central metal ion. Bidentate ligand. Bidentate ligand means the ligand which donate 2 lone pairs to the central metal ion or central metal atom. So option is the 3. Remaining ligands, this is monodentate ligand, carbonyl, cyanide, carbon monoxide is monodentate, cyanide is the monodentate, H2O is the monodentate, but only C2O4 is the bidentate ligand and chelating ligand. So option is 3. If we can go to 9th question. How many ions per molecule are produced from the complex CONH3 taken 6 Cl2 in solution. It means in aqueous solution, solvent is the water, CO, NH3 taken 6 Cl2 in water, dissociate into one complex ion, CO, NH3 taken 6 2 plus 2Cl minus 2 chloride ions. The 2 chloride ions mean Cl2. These are the counter ions. Counter ions, 2 chlorine atoms are present in the compound, 2Cl minus 1 complex ion, 2 counter ions, total 3 ions. We will get when this compound dissolved in water, 3. Option is the 3. Next question, students. Given below are two statements. Statement 1 is M bond C, sigma bond is formed by the donation of lone pair of electrons on the carbonyl carbon into a vacant d orbital of the metal atom. Here carbon monoxide is the ligand. Why carbon monoxide is ligand? Carbon has lone pair electrons between carbon and oxygen. Okay, between carbon and oxygen. Double bond is present or triple bond is present, students? By taking valence electrons. 1, 2, 3, 4. Carbon has 4 valence electrons. 1, 2, 3, 4. Oxygen has 6 valence electrons. 6 valence electrons. 1, 2, 3, 4, 5, 6. But by taking this structure, both the atoms are not getting octet configuration in their outermost orbit. Why? Because carbon has 1, 2, 3, 4, 5, 6. Once bond found between atoms, that bond pair or bond belongs to both the bond atoms. Okay, carbon has 6 electrons, but oxygen has 8 electrons. But this molecule is unstable. This is not correct structure. What is the correct structure for carbon monoxide? Carbon triple bond oxygen. Carbon has 4 valence electrons. 1, 2, 3, 4. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. This is the coordinate covalent bond. What is the main difference between covalent bond and coordinate covalent bond, students? In the formation of covalent bond, both the atoms are contributing and both the atoms are mutually sharing that bond pair. But in the formation of coordinate covalent bond, only one atom is contributing in the formation of bond pair, but both are mutually sharing. So lone pair present on the carbon atom, this lone pair is giving to central metal atom. So statement 1 is correct. Okay, donation of electrons on the carbonyl carbon into vacant d orbital of the metal. See, carbon monoxide is the ligand. Okay, ligand means the molecule or ion which donate pair of electrons. Which is taking is here, metal atom is taking. Metal is having empty d orbitals. These empty d orbitals are vacant d orbitals ready to take up the pair of electrons from the ligand. Statement is 1 is correct. Go to second statement. M bond C, pi bond is formed by the donation of pair of electrons from filled d orbital of metal into vacant anti-bonding pi star orbital of carbon monoxide. Statement 2 is also correct. This is nothing but the statement explain about the back bonding in carbonyl complex compounds or synergetic effect of carbonyl compounds. Here this the sigma bond is here. Whenever the electrons are more in d orbitals of metal, so electron density increases in metal atom. That's why electrons from metal to carbon increases. This is the pi bond. Okay, for receiving electrons, vacant orbital should be required. In carbon monoxide, okay, vacant antibonding pi star orbitals are present. These vacant orbitals are ready to receive the electrons from metal atom. That is back bonding or nothing but synergetic effect. So statement 1 and 2 are correct. 1 and 2 are correct. Both statement 1 and 2 are correct. Next, go to 11th question. This question is also belongs to coordination compound, students. Are you following, students? Yes. Next. Match the following. This is belongs to match the following type question. List 1, list 2. List 1 complex compound is given. List 2 geometry of that complex compound. Okay, suppose if you know one compound structure, easily you can give the answer. If you can take FeCO taken 5, D is the trigonal pyramidal. What is the hybridization of the iron in FeCO taken 5? sp3d. sp3d. What is the structure? What is the structure for sp3d hybridization? Trigonal bipyramidal. Trigonal bipyramidal. A trigonal bipyramidal. What is the trigonal bipyramidal structure? Fe, CO, CO, CO. 3 CO molecules arranged around the iron are equilateral, like this trigonal planar. Okay, two carbon monoxide ligands are axial or linear. This is the trigonal bipyramidal. This is one pyramid, students. This is one pyramid like this. This another pyramid is here. This is the another pyramid. Trigonal bipyramidal. So for D, what is the geometry? 1 is here. For D, which options are there? In option here in option 1, in option 3 is also. Go to remaining compounds. CONH3 taken 6. CONH3 taken 6 is the octahedral complex. Octahedral complex because of the presence of 6 monodentate ligands is here. Coordination number is 6. So A is octahedral complex. A is 2. Where is A is 2? Okay, A is 2. D is 1. A is 2. In which option A is 2 is there? A is 2. Okay. In option 1 is A is 2. But in option 3 is A is 3. So option 1 is the correct answer. B is 3. B is 3. This is a tetrahedral. Nickel has sp3 hybridization. Why? Because of presence of weak field ligand, that is chlorine. NiCN taken for -2. This is square planar. nickel has DsP2 hybridization, DsP2. This one sp3. Okay, octatal is D2 sp3. So answer is first option. Let us go to 12th question, students. Question number 12. Okay, students. 12th question. Here, this is also match the following. This is also match the following. B1 in list 1, B1, B2, B6, B12. List 2 deficiency disease, convulsions, RBC deficiency in hemoglobin, retarded growth, burning sensation on the skin. Burning sensation on the skin. Sisters, sorry for the delay. B1. Now I am going to give chemical name for vitamin B1. What is the chemical name for B1? Thiamine. What is the chemical name for B2? Riboflavin. What is the chemical name for B6? Pyridine. What is the chemical name for B12? Cyanocobalamin. If you don't know deficiency disease for all these vitamins, by knowing, okay, one vitamin deficiency disease, you can give answer easily. Suppose if you can take B12, cyanocobalamin, B12, cyanocobalamin, okay, that is RBC, red blood cells deficiency in hemoglobin. So D is, okay, 2. In which option D is 2? Yeah, second option, students. Okay, remaining A is 3. A is 3 is here B1. Retarded growth, thiamine. Next, B is 4. B is 4. B is 4 means burning sensation on the skin. Skin. Next, C is 1. Convulsions. Okay, now. And I gave B12 deficiency disease, RBC deficiency in hemoglobin. So you have to know the chemical name also, students. B1 is thiamine, B2 is riboflavin, B6 is pyridine, B12 is cyanocobalamin. Option is the 2. This question belongs to biomolecules, students. Even in it also, from some chapters directly questions will ask, critical questions. They are mainly biomolecules, D and F block elements, coordination compounds, and P block elements. Not only the P block, and one more chapter, hydrocarbons. Go to question number 13. All monosaccharides are reduced in sugars. Yes, it is correct. Statement 1 is correct. Statement 2. Sucrose can reduce ammonical silver nitrate. Ammonical silver nitrate. Sucrose does not reduce ammonical silver nitrate. Sucrose does not give ammonical silver nitrate, means tolerance test. Tolerance test. Does not give tolerance test. Why? Because sucrose does not have free hydroxyl group at first carbon, because that hydroxyl group is involving bond with beta D fructose, beta D minus fructose. No free hydroxyl group in the sucrose. That's why sucrose does not reduce ammonical silver nitrate or does not give positive test with tolerance reagent. So statement 1 is correct. Statement 2 is wrong. 2 is wrong. So statement 1 is correct. Statement 2 is wrong, means third option. What is the formula for ammonical silver nitrate? Ammonical silver nitrate Ag NH3 taken twice NO3, ammonical silver nitrate. Okay. Next, go to 14th question, students. Incorrect statement about alpha amino acids of proteins among the following. Among the following. Next. Methionine is an essential amino acid. Essential amino acid. Incorrect statement is asking. Incorrect statement is asking. Methionine is an essential amino acid. This is the correct, students. Because methionine is the essential amino acid. You can take that amino acid from the diet only, means from the food only. Our body cannot synthesize this amino acid. Next, glycine does not exhibit enantiomerism. Why? Because glycine does not have chiral carbon. Glycine is here CH NH2 COOH. This carbon is chiral carbon. Achiral carbon. If the compound is having achiral carbon, does not exhibit enantiomerism. So this term, okay, yeah, this statement is also correct, but asked incorrect statement or wrong statement. Next, here option 3, by taking option 3, glycyl anyl glutamine has 3 amide linkages. First one is glycine, next one is alanine, next one is glutamine. Okay, how many peptide bonds are present between 3 amino acids? First one is glycine, second one is alanine, and the third one is glutamine. Here these one peptide linkage or peptide bond, this is one peptide bond is here. Total 2 peptide bonds or 2 peptide linkages, but here given 3 amide linkages, 2 peptide linkages are amide linkages. Amide linkages means, okay, bond present between NH2 group and a carboxylic acid group. In carboxylic acid group, OH minus ion, in amide group, H plus ion goes out as a water molecule to form peptide bond or amide bond. 2 amide bonds are present, but here given, okay, 3 amide bonds. This statement was wrong. So asked incorrect statement. Answer is 3. Zwitterion of valine exhibit amphoteric behavior. This is also correct, students. Why? Because the zwitterion has both acidic and basic groups. So the zwitterion has amphoteric in behavior. Almost pH is equal to 7. So answer is third option, students. Next, go to fifteenth question. Match the list 1 and list 2 and select the correct option. Students, by knowing by knowing the matching of 1 or 2 compounds, you will get the answer, students. How will you get the no answer? See, students, suppose if you can take D, okay, in list 1, if you can take D, phenol. Phenol gives neutral ferric chloride test. Okay, whenever phenol react with the neutral ferric chloride test to give violet color. Next, students, by taking aniline give azodite test. Next, aldehydes to give tolerance test. All aldehydes. Okay, students. Here, next, alcohol steric ammonium nitrate test, CAN test. Primary and secondary alcohols will give CAN test except tertiary alcohol. So what is the answer is here, students? Okay, A is 3. In which options A is 3 is there? Option 3 and option 2. So here compound C, aldehydes, already given in aldehydes, ketones and carboxylic acid chapter, all aldehydes given tolerance test. So C is 4, amma. In which option C is 4? C is 4 in option 2 and 4. But go to remaining compounds. Option A, alcohols steric ammonium nitrate test. A is 3. So option is 2. Next, aniline azodite test. B is 2 is here. B is 2. C is 4, tolerant test. D is 1, neutral ferric chloride test. Answer is 3. Option is 3. Students, go to next question. Question number 16, students. Question number 16. First, everyone has to read the question, students, properly. Question number 16. When salt Ba is treated with concentrated sulfuric acid, reddish brown gas is liberated. The aqueous solution of Ba gives yellow precipitate with AgNO3 solution. Which of the following anion A is present in the salt Ba? Here Ba treated with H2SO4. Now I am going to write balanced reaction. Ba I am taking as NaBr plus H2SO4 by balancing 2 NaBr 2 H2SO4 give rises Na2SO4 sodium sulfate plus SO2 plus Br2 plus 2H2O. So now here, when salt Ba treated with concentrated sulfuric acid to give reddish brown gas liberated. Liberated is here. And then aqueous solution of Ba gives pale yellow precipitate with AgNO3 solution. AgNO3 solution. Ba, the compound Ba is the sodium bromide. That sodium bromide NaBr plus AgNO3 give rises AgBr plus NaNO3. AgBr is the yellowish precipitate. Pale yellowish precipitate. And Br2 liquid. Br2 is the liquid. Sorry, no, not Br2 is liquid. Br2 is the gas. This is a reddish brown gas. Reddish brown. Okay, color gas Br2. So Ba is the NaBr. Na plus Br minus. What is asked is here. Which of the following is A minus, anion? Anion is the Br minus. Fourth option is the correct, students. Next, go to 17th question, students. Which of the following represents de Broglie's equation? This is the direct question from the atomic structure. De Broglie's wavelength is equal to h by mv. H is the Planck's constant, m is the mass of the particle, v is the velocity of particle. The product of mass into velocity is the momentum, r equal to h by p also. Next, go to 18th question. For 17th question, answer is the h by mv. Next, go to 18th question. Which of the following is the correct statement about psi square? Psi square represent atomic orbit, not orbit is here. That is not correct. Okay. Probability density of the electron at that point. This is also not correct. Psi square represent the mostly about orbital, not orbit. And the probability density of the electron at that point. Okay, this is also not correct because the electron moves with high velocity. We cannot find out the exact position of the electron. Here psi square not equal to 0 for nodes. For nodes psi square is the 0, not equal to 0. 0 psi square. Psi square has no physical meaning. This is the correct answer. That psi square does not have any physical meaning. So for 18th question, answer is the fourth one. Question number 19. Entropy of a perfect crystalline solid at absolute zero approaches zero. This is the third law of thermodynamics. Entropy of any perfect and pure crystalline substance at absolute zero temperature is the zero. Absolute zero temperature means, students, 0 Kelvin. 0 Kelvin or minus 273 Kelvin temperature. At this temperature is the lowest temperature on the temperature scale, Kelvin temperature. At this temperature, no randomness or no disorderness in the given solid. What is entropy? Entropy is the entropy measures the randomness or disorderliness of a system. So very less temperature 0 Kelvin is the lowest temperature on the Kelvin scale. So no disorderness in the given system. So entropy is the 0 at absolute 0 temperature. It means 0 Kelvin or minus 273 Kelvin. So statement A is the correct. B, for spontaneity of a reaction T delta S greater than delta H, delta G is equal to delta H minus T delta S. This is the Gibbs-Helmholtz equation. Delta G is negative or less than 0 for spontaneous reaction. All naturally occurring processes are spontaneous reactions. Okay. So here for getting negative value, T delta S, temperature into change in entropy greater than delta H. Delta H. This should be greater than change in enthalpy. At that time only we will get delta G is the negative. Otherwise, if delta H is greater than T delta S, delta G is positive. Delta G greater than 0, it means positive means. So that if delta G is positive, reaction or process should be non-spontaneous, but here given spontaneity. So here A is correct, B is also correct. Both A and B are true. Okay, students. A and B are true. Go to 20th question. Which of the following is correct statement for thermodynamic system? Thermodynamic system. The internal energy change in all process. The internal energy change in all process. Which of the following is correct statement for thermodynamic system? The internal energy change in all process. First option. Okay. Next, second option. Internal energy, entropy are state functions. This is the correct. Okay. By taking the options, you will get the answer. Will you get now the correct answer? Internal energy, E, and entropy are the state functions. Why remaining options are not correct? Work is a state function. Work is not a state function. Work is the path function. This is the path function. And work done in an adiabatic process is always 0, not 0. Because work done is equal, okay, delta E according to first law of thermodynamics, Q plus W. For adiabatic process, Q is the 0. So delta E or change in energy is equal to work done. Work done is not equal to 0 for adiabatic process. So option 2 is the correct. The internal energy change in all the process. The internal energy change in all the process. This option is incomplete, students. The internal energy change in all the process. This sentence is incomplete. So whatever it is, but second option is correct or not? Both internal energy and entropy are the state functions. State functions they are. Okay. Instead of state functions, if they will give either extensive or intensive, internal energy and entropy are not depend upon the amount of matter present in the system. Not depend upon the amount of matter means not depend upon amount of the intensive property, their intensive properties. Next, students, go to 21st question. This question is related to thermodynamics. The gas can be taken from A to B via two different paths, ACB, A, C, B, ACB, and ADB, ADB. Now, here on y-axis enthalpy, on x-axis reaction coordinate. When path ACB is used, 60 joules of heat flow into the system. Heat flow into the system. Heat flow into the system. Heat taken by the system. Heat flow into the system means that is endothermic reaction. Endothermic reaction means work done by the system. Work done by the system. So according to first law of thermodynamics, delta E is equal to Q plus W. Q is given there. Q is 60 plus work done by the system. Here heat taken by the system and work done by the system. Work done by the system is here 30 joules minus 30. So here this is equal to 60 minus 30, that is equal to 30, students. Next, if path ADB work done by the system is 10 joules, what is the heat flow? What is the heat flow for ADB? Heat flow for ADB is asked here. Delta E is equal to Q plus W. But what is asked here? See, students, I'm going to continue question number 21. What is asked is here, heat flow into the system in path ADB. ADB is ADB, not ACB. Asked heat flow. Here, delta E is equal to Q plus W. Okay. Asked is here, Q is here. That Q is equal to delta E minus W. Delta E already I found 30. Delta E is 30. 30 minus what is the work done is here? Work done here, heat flow into the system in path ADB. Heat flow into the system means endothermic. Endothermic means work done should be negative. Work done by the system. So work done is here minus 30. 30 plus 30, that is equal to 60. Oh, so sorry, students. Okay, no option as 60. Sorry, students. Work done is given is sorry, students. Work done already given for AD path 10 is given. మళ్ళీ పోయి I did wrong explanation, students. I am going to explain one more time. I am going to explain about 21. Question 21. Question number 21 is here. Question number 21. See, students. Delta E is equal to Q plus W is here. That is equal to Q for ACP path, okay, 60 plus work done by the system. That's why negative sign with negative sign 30 joules. That is equal to 30. Delta E is the 30, okay, joules. But what is asked is here heat flow into the system in path ADB. Okay, delta E is equal, once again I am writing this equation, first law of thermodynamics equation, plus W. Q is equal to heat flow into the system in path ADB, delta E minus W. Okay, here delta E, I found that one 30 minus work done. Work done is 20. Okay, sorry, work done. Okay, work done by the system is 10 is here 10. Okay, here but this will be with the negative sign. Work done by the system. Why? Because work done by the system is 10. So 30 plus 10, that is equal to 40. This is the heat. So students, the heat flow into the system is 40. Okay, so answer is the 4. Answer is the 4. Next, go to question number 22. Question number 22, students. For the reversible process, N2 plus 3H2 gives rise to NH3. When the partial pressure is measured in atmosphere, the value of Kp at 500 degrees centigrade is 1.44 into 10 power minus 5. The value of Kc when the concentration is expressed in mole per liter is. First you have to know the equation relation between Kc and Kp. Kp is equal to Kc into RT power delta N. Delta Ng, change in number of moles of gaseous substances. What is asked is here Kc is asked. Kc, equilibrium constant in terms of concentration, Kp by RT power delta N. What is delta N? Delta N is the number of moles of product minus number of moles of reactants. Okay, that is equal to 2 minus 4 is here, that is equal to minus 2. That is equal to Kp value 1.44 into 10 power minus 5 by R value in lit atmospheres here, because Kc given in mole liter, asked in mole liter was. So R value 0.082 into temperature. Temperature is 500 degree centigrade. 500 degree centigrade. 500 degree centigrade means converting into Kelvin is here. Okay. 500 plus 273, 773 minus 2. So which option is the answer? 1.44 into 10 power minus 5 by 0.082 into 773 whole square. So third option, minus 2. Minus 2 means fourth option, students. Fourth option. Fourth option. Next, go to 23. Question number 23. The following gas is reversible reaction. 3A plus B give rises A 3B. Enthalpy of reaction is minus Q. Enthalpy of reaction is minus Q. It means exothermic reaction. 3A plus B, 3A plus B give rises A3B. Delta H is equal to minus Q. This is the exothermic reaction. So the amount of product A3B is affected by, okay, temperature is affected. Okay, this reaction was affected by temperature. Why? Because this is exothermic reaction. For exothermic reactions, okay, low temperature is required because already heat is evolving from the reaction, and the pressure is here, and the pressure also. Why pressure? Here total number of volumes of reactants 4 volumes, 3 plus 1. Total volumes of products are is here 1 volume, 4 volumes. This is 4 volumes. Four volumes. Yeah, this is 1 volume of the product. Here volume decreases or reduces. Okay, volume reducing means at high pressure. Otherwise, if delta n, okay, here delta n, change in number of moles of gases, okay, less than 0. Less than 0 means is here 1 minus 4 is here, that is equal to minus 3. High pressure should be required. High pressure. So both the temperature and pressure affected. Both temperature and pressure are affected for this reaction. Next, go to 24th question. .15 mole of pyridinium chloride has been added to 500 centimeter cube of 0.2 pyridine solution. Pyridine solution is the base. Assuming there is no change in volume upon mixing, the pH of the solution. Here pyridine is, students, base. So you can find out pOH. pOH is equal to pKb. plus salt by okay base, salt by base. The concentration of salt is here. Salt concentration I is equal to nothing but molarity, number of moles by volume is here. Salt is pyridinium chloride 0.15 mole, 0.15 mole, 0.15 mole. Okay, is added to the 0.15 mole by volume is here 0.15 mole of pyridinium chloride has been added to the 500 centimeter cube, means 500 ml of 0.2 molar pyridine solution. Okay, here now this is 0.15 by this is the number of moles, volume 0.5, volume is this is equal to 0.3. Next, base concentration is equal to number of moles by V. This is also equal to here base 0.2 by 0.5, 0.2 by 0.5. This is equal to 0. 0.2 moles. Okay, 1 minute students. Sorry. Molarity, number of moles by volume. Here this one. Base is equal to here molarity is equal to molarity number of moles here. Molarity is equal to number of moles by volume. Here number of moles is equal to molarity into volume. Molarity is here 0.2 into volume 0.5 is equal to 0.2 into 0.5 1 by volume. 0.5 is here. This is 2. So now POH is equal to here PKB of pyridine. Pyridine is the base. PKB is equal to minus log KB. Actually students, KB value has to give. KB value was not given in the question. That is here minus log KB value. If you can go through amines chapter, amines in the amines chapter, pKb values are given, or otherwise in ionic equilibrium, minus log Kb value is here, Kb value, that is 1.7 into 10 power minus 9. You will get approximately, this is 8.77 pKb value. This is the Kb value. Okay na? Here pOH is equal to 8.77 plus salt is here 0.3 by 0.3 by okay 1 into one students 0.3 by 0.2 because of 1 into 10 power minus 2. Okay, this is 0.2. 0.2. Here 1.5 log sorry students, log, this is 1.5, pOH is equal to 8.77 plus log 1.5 . Here log 1.5 value, almost 1.5, log 1 is 0, log 1.5 is here almost 0.20 also we can take, not a problem. Here 8.77 plus 0.176, 0.18 otherwise. Almost this is equal to 9. But here pH plus pOH is equal to 14. pH is equal to 14 minus pOH, that is 14 minus 5 is equal to 9. Sorry. 14. Okay, that is equal. 1 minute. 9 students. pOH is 9. Okay, 9. That is equal to 5. 5 is the answer. First option, students. Here question number 25. Which of the following is correct with respect to the property mentioned against it? Okay, now here osmotic pressure at 298 Kelvin, osmotic pressure. Okay, against it is here asked, means osmotic pressure. Which of the following is correct? Okay, with respect to the property mentioned against it. Okay, see students, against it means wrong is asking. Okay, osmotic pressure at 298 Kelvin, 0.1 molar NaCl solution less than 0.1 molar urea solution. Here NaCl solution osmotic pressure is more than because of number of particles are more is than urea. Okay, now, but here wrong is given. Which of the following is correct with respect to the property mentioned against it? This is the wrong. Next, here concentration of NaCl in the solution is 2 ppm. Means here if you can go through this question, 2 ppm means 2 particles are dissolved in 10 power 6 particles of the solution. Greater than 2 molar. 2 molar means 2 moles. 2 moles here, 2 moles of particles in 10 power 6 10 power 6 moles of the solution. Here 2 molar means 2 moles present in 1 liter of the solution. 1 liter of the solution. This is okay. This is also wrong. Next, delta TB. Delta TB of NaCl solution is more than urea solution. This is also wrong because number of particles are more is here. Colligative property Cp directly proportional to I into concentration. A 2 ppm is less than 2 molar because the 2 particles here present in 10 power 6 liters of solution, but 2 moles present in 1 liter of solution. Vapor pressure is here. Salt water vapor pressure is lesser than the pure water. This is the correct one. Option 4 is the correct. Why? Because salt water, salt is forming as a layer at the surface of solution that prevents the evaporation of the solution. So fourth option is the correct. See, question number 26, students. This chapter is related to solutions, thermodynamics and electrochemistry. By matching of 1 or 2 compounds, you will get the answer. Suppose if you can know Henry's law is here P is equal to Kh into X, A is equal to 2. In each options, A is equal to 2, option 2 and 3. Next, go to Raoult's law. Raoult's law is here partial vapor pressure of the component is equal to mole fraction of that component into partial vapor pressure of the pure component. Okay, so B is 1. In both options, B is 1 is there. Next, first law of thermodynamics. C is equal, delta E is equal to Q plus W. So C is 4. So option 3 is the answer. Next, Kohlrausch law. Limiting molar conductivity is equal to nu plus lambda naught plus V minus lambda naught minus. So option 3 is the answer. Next, 27. When 0.0106 moles of acetic acid was dissolved in 1 kg of water, the freezing point depression for this strength of acid was 0.0205 Kelvin. If the calculated freezing point depression is 0.0197, Vanta factor I and degree of dissociation of acetic acid respectively. Okay. Here I is equal to Vanta factor, observed colligative property observed colligative property by calculated colligative property. Observed colligative property given, students. Okay. Here if the calculated freezing point of the depression was given, that was 0.0197 students. Observed one you have to find out. Delta TF is equal to KF into molality. KF was given is here. KF was given here 1 kg of 1 kg of water. KF students. KF value and KB values you have to remember students. 1.86 almost. 1.86 into molality 0.0106. The freezing point depression for the this one was given the freezing point depression of this acid was given already directly. No need of calculation of the delta TF. Zero point zero 106. This is equal to 2 digits. I am going to take to right hand side 1 by almost 1.06 by 1.97 is here. 1 by 2 almost here. This is 1 by 2, that is equal to 0.5 students. I value is equal to 0.5 I value. Alpha for the dissociation I minus 1 by n minus 1. Sorry students, here observed depression freezing point 0.025 by calculated depression freezing point was 0.0197. Here 2.05 by 1.97 is here, approximately 2 is here. I value is equal to 2. 2 minus 1 by 2 is here. 2 means nearby. Here now 1 students, 1 only. Sorry students. More than 1 students. Here I value is equal to 1.041. I value in second option, fourth option, I is equal to 1.041, 1.041. I is here, I is equal to now 1.01. That is, otherwise I am writing separately. One point 041 minus 1 by here acetic acid in water dissociates into ions CH3CO minus and H plus ions, 2 number of ions in the water, 2 minus 1. 0.41 0.041 by 1 0.041. So answer is 4. Fourth option is the answer. Next, question number 28. The relative lowering vapor pressure produced by dissolving 18 grams of urea here relative lowering vapor pressure of solution directly proportional to mole fraction of the solute, that is equal to number of moles of urea by number of moles of H2O. Number of moles of urea, weight by molecular weight 18 grams by 60. Okay, in 100 grams of water 100 by 18. This is one fraction, this is one fraction. Here 5.5. Okay, here now 6 into 3 is here, 6 into 10 is here. So now 3 by 10 by 5.5 is here. Zero point 3 by 5.5 is here. What is the answer, students? 3 into 30 into 10 power minus 2 by 5.5 is here. This is here almost, okay, 30 is here. Here now 5 is here, almost 5 is here. 5 into 5, 25. Okay, 5 point almost here 5. 0.05 is the answer. Next question number 29. Question number 29. During the electrolysis of acidified water, 16 grams of O2 gas is formed at anode. The volume of H2 gas liberated at cathode is STP. Here H2O give rises H2 plus half O2. H2 plus half O2. Here half O2 is here 11.2 liters. So 11.2 liters. 1 mole occupies 22.4 liters. Half mole is here 11.2 liters. Already given. Okay. Here 16 grams of O2 at anode is here. 16 grams of O2. 16 grams of O2 means here half O2. 16 grams only. 16 grams. That is here 11.2 liters. Here H2 is 1 mole. This is here 1 mole. 1 mole is here occupies 22.4 liters. So answer is 22.4 liters. H2 gas liberated cathode is 22.4 liters. Okay, students, next. Question number 30. Lambda naught NH4OH ammonium hydroxide is equal to. This question belongs to electrochemistry. lambda naught m infinite molar conductivity of NH4OH is equal to lambda naught m NH4Cl ammonium chloride plus lambda naught m NaOH minus lambda naught m NaCl. Why? Because this compound dissociate into lambda naught NH4 plus lambda naught Cl minus. This compound dissociate into lambda naught m Na plus lambda naught m OH minus. This is the minus, that's why minus lambda naught m Na plus minus lambda naught m NaCl, sorry, Cl minus plus lambda naught Cl minus lambda naught Cl, okay, plus lambda naught Na plus minus lambda naught Na plus. So lambda naught NH4 plus sum of infinite molar conductivity of ammonium ion and lambda in hydroxide ion, that is equal to infinite molar conductivity of NH4OH. So option is the lambda naught NH4Cl plus lambda naught, okay, NaOH minus lambda naught m NaCl. Students, till now I completed half of the paper, means almost 30 exact 30 questions I completed. Tomorrow I am going to explain remaining questions, students. Thank you.